Lesson 8 goes into analyzing bivariate data, and we're going to be analyzing data like a pro. So to be successful, you are going to be able to analyze a set of data to determine associations between two variables. So we start by looking at the speed versus step length in the warm-up. And it talks about a researcher who found an association between a dog's stride length and its speed. The longer a dog steps, the faster it goes. The predicted speed in meters per second, S, as a function of step length in meters L, is shown by this equation here. What does the rate of change of the function tell you about the association between stride length and speed? Take a moment and think about that question. So this actually tells us that for every 1 meter, increase in a dog's length, its speed increases by 4 meters per second, which we see in the equation. And we would identify that as the slope if we were technically speaking. Which is also, we would say, our rate of change. Okay, so we've talked about using equations to model our data to make predictions. This is just another example. Okay, this next activity, we're looking at animal brains. And you have a table. It gives you different animals, their body weights, and then it gives you their brain weights. And we're trying to see if there's an association between the weight of the animal's body and the weight of the animal's brain. So you are given a blank scattered plot. You're going to plot the weights in comparison to the body and brain. And then you're going to be looking for any outliers to determine if you need to remove them. And then trying to see if there's an association between the body weight and the brain weight, describing it in a sentence. And now you don't have a piece of pasta here, but we did talk about creating a blob. Create a blob around your data and cut in half with a line using a straight edge, so you can go ahead and do that. And then thinking about what does the slope mean in context of the problem. So really analyzing that situation. And then does the fitted line help you identify more outliers? So you're going to take some time to do that on your own. Pause the video, and then when we come back, we will actually have something graphed here on the scatter plot to show you. Okay, so let's first talk about what we consider to be outliers. I'm going to actually go ahead and show you a scatter plot with a line already created. So you could kind of see here that that point way up at the top looks to be the chimpanzee is really what it is. Let me go to my table here. So that chimpanzee, which was 52,440, is an immediate outlier that you should recognize. So you should have been able to see that right away. Oops, let's see, where's my... And then how did you determine your fitted line? And then hopefully you guys did draw that blob and cut it down the middle, and it should look very similar to this. And then once you have that line, it really should help you identify more outliers. I think that's in my next slide. Let's see, it keeps going away. But really, I would say majority of the data is pretty much in line with the trend, minus that chimpanzee. Let's assume the trend you found continues past the end of the scatter plot. A Tyrannosaurus rex is a dinosaur that is estimated to have a body weight of about 8,000 kilograms. Now, I'm going to just on the side here, let's see if I could scoot this over, kind of just draw in so you can see that this would have to keep going and we would be looking for 8,000 kilograms. But it's going to be hard to kind of make that estimate. So we might want to think about some other components of our prediction line that would help us maybe decide on what we would expect its brain weight to be. So kind of looking at that line, I'm going to try and draw the line in without the data points. Let's see. Looks like it's going right under the 200 mark. 200. And I think like right here is like pretty close to it. Pretty close enough line. So like you want to start thinking about their lines maybe a little bit up, but you want to start thinking about using that line for that prediction piece. And so maybe we start to think about like, what is the slope of that line? You know, maybe creating some slope triangles, thinking about what that rate of change is, maybe estimating that, you know, this is 100. That maybe it's changing, you know, as the body weight increases by 1. Because here you can see that's an increase of 100. From here to here is an increase of 100, right? So it's helping you make kind of an estimate. We can maybe say that as the body weight increases by a kilogram, the brain weight increases by a kilogram. So almost looking at it as, let's maybe say, body to brain, we might say is 1 kilogram to 1 gram, right? So if we're thinking about an 8,000 kilogram, 8,000 kilogram body, we might expect to see that also around 8,000 grams. So just kind of making sense of that. Now again, that's not necessarily means it's going to be true, but that's a predictor line, and you use that slope and the line to kind of help you make all those decisions. Okay, so let's just keep in mind again that our criteria is to analyze a set of data to determine associations between 2 variables. And in this last activity, our 2 variables were body weight and brain weight. And now we actually are going back into the body dimensions that we took early on in lesson 2. So for the sake of the video, I'll be using the data that was collected in my classes during class and showing you that information. If you had collected data with your class, go back and use your own class's data for consistency. So we talked about measuring arm span, we did height, we took hand span, we did our birthdays in terms of months, and that data has already been collected. My students can find that on Hapara under the lesson 2 card for your class. So you're going to use that data and you're actually going to create a scatter plot. And this is going to be some really tedious work. It's going to take you a minute. I actually created scatter plots already for both of my classes, which I'll share in a moment. But think about, you know, organizing the data. It should already be, I think I'll have it left in terms of our arm span from least to greatest, which should make it a little bit easier for you guys. And then you'll just have to kind of compare it to the height. And then you're going to actually create that scatter plot. So I'm just going to kind of sketch. You're creating a scatter plot. You're going to label each of the x-axis and y-axis. You're going to think about, what do you want to scale by? Do you need to start at 0? Can you start at a different number? Do you need to label every line? Can you skip every line to just save some space? Once you have that scatter plot created, you're going to go ahead and answer questions 3 and 4. And then that's what's really going to allow you to analyze all of the data. Okay, so go ahead and start working on that. And then I'm going to go ahead and pull open mine that I drew. Okay, So here is my block 2's class, which shows their arm span in centimeters to their height in centimeters. And there were actually two values I decided not to plot as part of my data. And the reason being is, one, this first one, I believe that there was an error in typing in the arm span of being 5. That didn't quite make sense, and I didn't want to start my scatter plot all the way at 5. And then this other point just didn't really necessarily fit in with the rest of the data, so I left it out because, again, I wanted to start my graph at 130 and I didn't want to start at 75.4. So that was the reason for just leaving that other one out. So as I start to kind of analyze this, I'm looking to see if there are any outliers, and then if there's an association between the body weight and the brain weight. And I do see an association. I believe that there is a pretty positive linear association between the body and the brain. The more I started to plot, obviously a lot of the points are kind of scattered. Let's see, kind of scattered in like this range right here. But I still felt that if I were to have collected more data for maybe older, or not older students, for people that had wider arm spans, I would have maybe saw more data to the right there. And then what was kind of validating is when I looked at block 4's. So here's block 4's data, which was actually kind of interesting because this looks like it's a little bit more clustered. Excuse me. So I felt like this was kind of not as in line with the rest of the data. But I do feel like everything else pretty much had a positive association. Excuse me. Okay. So in just kind of thinking about that, the question then takes us to, is the line y equals x a good fit for our data? If so, explain why or why not. And I would say yes, that the line, I'll write it on here, y equals x, is a good fit. Generally, human arm span and height are actually about the same. So typically, arm span is equal to the height when you're measuring in the same unit. Now, again, you have to account for like measuring error, typing errors, things like that. Just a lot of human errors. But generally, this is what we typically kind of see happen. Let's see what else I got here for us. What is the slope of the line that best fits the data? Based on what we just kind of talked about with this equation here, we would say that the slope of the line should be close to 1. What would a point on the line y equals x represent in our graph? Well, it's going to represent a person whose arm span and height are identical. It doesn't matter which way the axes are drawn for this line. So if you maybe had them reversed, that's fine. But typically, we should see that they're pretty close to being the same. What does it mean about a person whose point is above the line? And then what about below? Well, depending on the axes, a person whose point is off of the line has a longer arm span than expected for the height, or is taller than expected for the arm span. And if I were to draw a line in here, which I will do, let me scooch that over. Let's see, close to here. I don't really like that line. That's not as good. Let me grab a color. And I really might even use my blob here. I might even say like this data, I might even say I'm going to include this data and then leave like the rest out. Might be something I do. Because then you're going to see that's kind of close to the line of y equals x. And even if I were to do the same. So I might say that these are maybe outliers. Maybe if that's how I analyze the data. Okay, so suppose You measure height and arm span for people in your neighborhood. When you make a scatter plot, you notice two clusters of data, one group of data in the lower left of the scatter plot and another group in the upper right. What does this mean, and why do you think there may be these clusters? Well, it might just depend on the age of the people that you took in your neighborhood. So it might mean that there are a lot of small children and a lot of tall adults, right? So there might just be an equal amount of those categories, and that's why your data appear to be clustered. So what does a point on the scatter plot tell us? In general, it tells us the two measurements about an individual in a population. In terms of what we looked at, it told us about their arm span and their height. What is an association between variables? A trend that suggests that as one variable increases, the other variable tends to increase if it is a positive association, or decrease if it's a negative association. What does a fitted line tell you about the data? It represents a model that can be used to make predictions about the dependent variable based on the value of the independent variable. And what does the slope of a fitted line tell you about the data? It tells you the amount the dependent variable will increase or maybe decrease for a 1 unit increase in the dependent variable. So kind of like we kind of seen that in both of those components, especially if we go back to the one about the body weight. We said as the body weight increased by 1 kilogram, the brain weight increased by 1 gram, actually, which we saw right there. Okay, so you have a lesson summary to read over to kind of help you just summarize all these components. Data analysis usually follows those 4 steps. So collecting data, organizing data, which we learned early on in our unit, identifying outliers, and trying to explain why these data points are exceptions to the trend, and then find a function that fits the data well. And we've modeled that as a linear model, right? A linear using that line or writing the equation. So do you feel confident that you can analyze a set of data to determine associations between the two? If you do, you have mastered that criteria and you're ready to move on to the practice. For my students, that's going to be numbers 1 to 3 on page 61 to 62.